This is the second video following up on the trig introduction one. Here we are actually going to work some problems. Now, just as a reminder, we're going to just look at the sine and cosine in this video, look at tangent in the next one. So sine and cosine have a very special relationship because we're dealing with complementary angles. When I talk about the sine, I'm talking about the opposite over the hypotenuse, and the cosine, which is a literal translation, meaning the complement of the sine. To illustrate this, let's take a look at this. When I have, say, angle theta, my reference angle is 50. My complement, of course, is going to be 40 degrees. So when I do the sine of 50, or the sine of theta, it is basically the opposite over the hypotenuse, which I have sine of 50 degrees, is equal to something. I don't know what that something is. It's going to boil down to a ratio, but I won't know the side lengths. Now when I do the cosine of theta, it's going to be the adjacent over the hypotenuse. But when I do this one right here, the cosine of 40, guess what? This is now the opposite, and this is the hypotenuse. So, and this is the adjacent right here. So cosine is adjacent over hypotenuse, which is exactly the same thing as this. So let me show you on the calculator. I'm going to go ahead and do, let me get this button, the sine of 50 degrees. And we're in degree mode. So it's about 0.766. So whatever those numbers are, the ratio boils down to that. Let me do the complement, the cosine of 40 degrees. And I'm going to get the exact same thing. So that's just one neat definition. So you can have multiple approaches to solving problems. Here's our first problem. We're going to solve for x and y. I always go, every single problem, I'm going to the reference angle. Right here. Now I can take the complement and work with that angle as well, but I'm going to be lazy. I'm just going to work with this one. So when I want to find the sine, which of course is opposite over hypotenuse, I write the function, this is my function statement, the sine of 26. That 26 is my independent variable. And we have opposite over hypotenuse. Then we solve it just like any other algebra problem. This whole thing represents some kind of decimal. As we saw over here in the calculator, is just a simplified fraction in decimal form. I'm going to treat this just like an equation. When I want to get rid of the denominator, I multiply by 14 on both sides, and I have 14 sine 26. This is some kind of decimal number, and this is 14. And it's going to equal to my sine now. Remember in the first video, I talked about how all circles are similar, and we have scale factors or dilations. This is how we're working to solve for that dilated length outside of the unit circle where the radius was 1. The radius is 14 here. So we're multiplying the sine 26 by the dilated factor, scale factor of 14. Alrighty, and that, of course, will get us a decimal answer. Now, be forewarned, sometimes I'm going to want exact answers, and sometimes I'm going to want decimal answers. This side length is approximately 6.137. Now, of course, in a word problem or application problem, we either round to the nearest tenth or something like that, which means it will be a broken triangle, just like in the first video. But this is a pretty darn good approximation. And when we want to find the y, we use our reference angle. This is adjacent hypotenuse, so we're going to use the cosine. Cosine of 26, there's my independent variable, that's my function, of y over 14. Treat this just like a number, and we have 14 cosine 26. Again, my dilated factor is equal to that side length. When I say I want an exact answer, this is what you're going to write down. We may or may not give you calculators on everything we do. In college, I never touched them. I had to use trig tables when I wanted to get to an approximate. So 14 cosine 26 gives me that. And this is solving the triangle. When I say solve a triangle, I'm going to want both angles. Of course, that's just the triangle sum. And then we're going to solve for the missing sides. Let's do another example. This one is going to be a little bit different. I'm just looking for x. I look for my reference angle, this angle right here. I could go with the complement, but why bother? I associate this side with the adjacent, and that's my hypotenuse. So I just set up my function, cosine 38 is equal to adjacent over hypotenuse. Treat this as a number like anything else. Algebra, I multiply by x on both sides. I have x cosine 38 is equal to 7.8. Well, I need to isolate my variable, my x. So I'm going to divide by cosine 38. X is equal to 7.8 over cosine 38. And if I want that as an exact, that is where I end. If I say find the approximate value, I go to my handy dandy calculator right here and do 7.8 divided by cosine 38. And boom, I have 9.898 blah, blah, blah. And just round to whatever we tell you to do. It's going to change frequently depending on the circumstances. All right, so that's how you work your basic trig in solving right triangles. And I can continue and find this length right here, but I'm going to have to use the tangent function. But we're just limiting to sine and cosine today in this video. Now, going backwards, I'm not telling you what the angle is. This is still my reference angle. That x is my independent, the x degree is my independent variable. So I'm going to look to see what's given. I have an opposite and a hypotenuse. That's going to be sine. So I'm going to actually have sine of x is equal to opposite over hypotenuse. This is a bit of a problem. There's only really one. You can solve it either with trig tables or with the calculator. So we're going to use the inverse. And I'm going to do my ratio right here is equal to x. So I'm doing the inverse function. In algebra, when you did y is equal to 2x plus 1, and they ask you to find the inverse of it, f of whatever, okay? This is from Algebra 1. You just swap the x and the y. You did x is equal to 2y plus 1 and resolve for y. We're doing the exact same thing right here. That's why they did inverse functions in your algebra class. Well, they did it for many other reasons too. So calculator comes to our rescue. We just have to hit the shift, sign inverse. I use the fraction button a lot, but you don't have to. And 10, and that gives me the angle of approximately 44.427 degrees. So about 44.427 degrees. Generally, we round to the nearest tenth on angles. Some teachers, myself included at times, will say go to the nearest degree. And again, that will be a broken triangle in reality because we rounded. But when we're doing word problems, it's not that big of a deal. Alrighty, one more tidbit. And here's a typical word problem. And we have a pretty sizable thing, 1,200 feet. So I'm going to look at my independent variable. This is called an angle of depression because we're looking down. And I'm given the opposite, and I have the hypotenuse. That's going to be sine. So I'm going to do sine of 21 is equal to opposite over the hypotenuse. So I'm going to do my algebra. X sine 21 is equal to 1,200. And then I'm going to get my variable isolated over sine 21. And I'm going to, that's my exact. So if I say find the exact value, that's where you stop. If I say the approximate length, round to the whatever. And on this, we'll probably round to the nearest foot. Sine 21. And we have x equal to about 3348.5. And if I said round to the nearest foot, it'd be 3349. All right. Now, when always doing these videos, you should be putting them on pause and working these problems yourself because you do not learn by watching, you learn by doing. All righty. I'll get this posted shortly.